And here what I would like to do is actually do one of two. I just finished two of two. This is latitude and the angle of the sun, changing angle of the sun. You may notice that we've got a little bass in the background. We've got a pretty decent thunderstorm coming through. This is a site called weatherbell.com, which you can do lots of cool things. But this is the front. I'm about right here. This is the front that's just getting through and making all the racket, and we got a bigger one coming in. You can actually see hail. This one's moving, looks like about 5 miles an hour. This one was moving more like 15 miles an hour, but you can see it's going to break up. It's in the 70s over here, 80s over here, and we're in the hundreds. So this cold air is moving in and going to give us a respite from these triple-digit numbers. It's only 99. This is a site that's called Weatherbug, and I don't care about that. Lake Braddock's saying it's 86. That may be a little colder, a little warmer than what they're. Maybe a little warmer than what they're showing, but it's close. Let me get back to this. Latitude, the angle of the sun. This is one of one. This is a picture of the Earth, and this is the apparent change in the sun's angle based on the Earth's tilt of 23.5 degrees, where June it's way up here, showing directly on top of the Tropic of Cancer, and way down here December 21st, the winter solstice, Tropic of Capricorn, and then on the two equinoxes, September 22nd and March 21st, it's actually right on the equator, and it progresses up from March to April, gets higher in the sky to a point where it's the highest in the sky. And for us here in Virginia, it gets up into the mid-70s in terms of angle. And then 6 months later, crosses the autumnal equinox, where the entire planet gets 12 hours of daytime and 12 hours a night. And this is the day that the northern hemisphere, the North Pole, kisses the sun goodbye. It's actually the first day for the South Pole to actually see the sun, and then South Pole gets more sun, North Pole gets more darkness, and then it gets down here to the winter solstice, and then it moves back up to the vernal equinox, then back up to the summer solstice, and just keeps doing that. The trip isn't exactly this easy. There's something out there called the dilemma of the analemma. This is the way it really works. Summer is highest, winter is lowest, and the equinox is right in the middle, but it spends more time in the lower section, moving faster, than it does in the upper, moving slower, and this has to do with the fact that the Earth's orbit is not exactly circular, it's elliptical. The sun does move faster in one part than it does the other. This is the one I want you to see. If the sun's directly above your head, the sun sends out 342 megawatts per square meter. If it's directly above here, doing the same thing, sending 342 megawatts per square meter, but only 243 make it to the ground. So at 45 degrees, the sun's energy actually decreases about 60%, loses 100 megawatts. If it was even lower in the sky, it would lose even more, and then if it's actually right on your horizon, you receive almost none. Okay, so here are three pictures. Summer solstice, where the sun is actually highest in the sky. The Earth is tilted in toward the sun, directly above the Tropic of Cancer, up there. So they get 12 hours of daylight and 12 hours a night. The North Pole gets 24 hours of daylight, because you can see as it spins, it never gets below the horizon. We here up here around 39 degrees up, we experience 15 hours of daylight and only 9 hours of darkness as we rotate. We get 12 hours of each, and the equator pretty much gets 12 hours of daylight and nighttime all year. Tropic of Capricorn down here only experiences 9 hours of daylight and 15 hours of darkness. And this again, this is called the summer solstice. And then we go down 6 months later. This happens on right around June 21st, which is my wedding anniversary. This happens right around 12/21, really close to our winter break here in high school. This is called the winter solstice. And this happens when the sun's energy strikes more directly on the Tropic of Capricorn, which again gives us only about 9 hours of daylight and 15 hours of darkness. The equator gets 12 of 12. The North Pole hasn't seen the sun in 6 months. Up here, the South Pole hasn't seen it in 6 months, and here they get to see it 24 hours a day. This is the Antarctic Circle. This is the Arctic Circle, which is the southern's most extent of sun's rays, or the sun's lowest extent of sun's rays. Capricorn and Cancer. So this is the winter solstice, and then this is going to be called these are all called equinox. I only posted one here because we actually have one that's called from winter to summer. It's called the vernal equinox. And from summer to winter, we call it the autumnal equinox, where the entire planet, North Pole to South Pole, experiences 12 hours of daylight and 12 hours of darkness as it moves around in a counterclockwise direction. Here's a picture sort of showing all three. If you're located right here, this is an observer where it almost is directly above your sky, a little higher than what it gets where we're located, but it gets about 75 degrees up there. They're saying it's 73 degrees, angle of noon. The meridian is the line that goes from your south compass point directly to your zenith, which is up there, and then down to your north compass point. So at 12 noon, you actually get 73 degrees of sunlight. Back on the equinoxes, this is the summer solstice, this is the winter solstice, and this is the equinox. Depending if it's moving from summer down, we actually call it the autumnal, and if it's moving from the winter up, we call it the vernal equinox. But 12 hours of daylight, 12 hours of night, right around 51 degrees here in Northern Virginia, and then 26 degrees for the winter solstice. And again, we only get 9 hours of daylight there. We get 12 hours of daylight for this one, and we get 15 hours of daylight here. Okay, then we move down to this location. This picture is actually showing the sort of same thing. Here's the sun. It's not showing a real ecliptic. It actually shows you December 21st and June 21st. The actual closest Earth to the sun, farthest Earth from the sun is located right there on July 4th. And then the closest one is over here for January, right around the 3rd. This is called perihelion because it's closer, and this is called aphelion because it's farther. Helion meaning sun, para like a periscope meaning close, and ap meaning farther away. But if you take a look at it, we have the North Pole, sun is just rising. This is the vernal equinox. Let me pick a different color. This is the vernal equinox. This is the autumnal equinox. This right here would be the winter solstice, and this would be the summer solstice. This one located right here, this is the one on March 21st or 22nd. Sun is just rising for the North Pole. The equator gets 12 hours of daylight, which also equates to 12 hours of night. South Pole, the sun is just setting. They're going to kiss the sun goodbye for 6 months, and then the sun gets higher and higher and higher in the sky. It's going from about 26 degrees way over here for us here in Virginia to right around 51 degrees for here on the vernal equinox. It gets higher and higher and higher and higher in the sky to about 75 degrees, maybe 74 degrees, located here in the summer solstice, and it goes back down to 51 degrees. So the changing angle of the sun based on latitude, I can actually draw something right here. If the sun is on the Earth's equator, it's located at 90 degrees for somebody who's actually located on the equator. It's located at 0 degrees for somebody that's located up here at the North Pole or the South Pole. And it's located for us here in Virginia at 51 degrees. So, and then if I was going to draw something up here, let's say you were located not at the equator, what if you were located at the North Pole? Actually, let's make it the South Pole since I got more room. And let's put the sun in 3 locations. Let's put it down here for the winter solstice. And if you take a look at it, and that's, if you can hear my text, that's George Mason telling me there's a thunderstorm outside. If you put the sun there at the 2 equinox and you put it there at the summer solstice, so this is the winter, this is the summer, and this is the equinox. And if you take a look, as it moves from winter solstice where it's higher in the sky, it gets lower in the sky. In fact, for the summer solstice, it's not in the sky at all. So if I actually move my body here, it gets higher, higher, and I can see it. Move my body there, you get these locations. So that if you change your latitude, you change the angle of the sun. And that's all latitude, angle of the sun in a nutshell. Thank you much for stopping by.